Integration. If we have a function such as y equals x cubed minus 5x squared plus 3x minus 2, we can find the gradient function dy by dx. So, y equals x cubed minus 5x squared plus 3x minus 2. Then dy by dx is equal to 3x squared minus 2 times 5x to the power 1 plus 3 minus 0, which simplifies to dy by dx equals 3x squared minus 10x plus 3. If we are given the gradient function, can we reverse it to find the original function? This reverse process is called integration. To differentiate, we multiply each term by its power and then reduce the power by 1. So, to integrate, we increase the power by 1 for each term and then divide by the power. So the integral of ax to the power n is equal to ax to the power n plus 1, all divided by n plus 1. Note, if you're just integrating a number, such as the number 5, that can be written as 5x to the power 0, so we increase the power to 1 and divide by 1. That gives us 5x to the 1 over 1, which is equal to 5x. It's easier to remember when integrating a number, we just multiply it by the variable. Now if we go back to our original example, after differentiating we had dy by dx is equal to 3x squared minus 10x plus 3. Or we can write that dy by dx equals 3x squared minus 10x to the power 1 plus 3x to the power 0. So when we integrate, the 3x to the power 2 becomes 3x to the power 3 over 3. The minus 10x to the power 1 becomes minus 10x to the power 2 over 2. And the plus 3x to the power 0 becomes plus 3x to the power 1 divided by 1. Now that simplifies to y equals x cubed minus 5x squared plus 3x. However, this does not get us back to the original, as we do not have the constant term minus 2. In this case, it's not possible to work out what the constant term was, as all constant terms differentiate to give 0. The best we can do is to give the answer as y equals x cubed minus 5x squared plus 3x plus c, where c is an unknown number or constant. This is called an indefinite integral. It may be possible to calculate c from other information given in the question, in which case it's called a definite integral. Let's look at an example. Integrate the following functions. Now the first one, we've got x to the power 7. So if we integrate x to the power 7, we have x to the power 8 over 8. But whenever we do an integration, we must add on at the end a plus c in case there was a number which had been differentiated and disappeared. So in part 2, if we're asked to integrate 36x squared, that's 36x to the power 2, we have 36x to the power 3 over 3 plus c, which is equal to 12x cubed plus c. In part 3, we're asked to integrate 6x squared minus 8x plus 3. Now the 6x to the power 2 becomes 6x to the power 3 over 3. The minus 8x to the power 1 becomes minus 8x to the power 2 divided by 2, and the plus 3 becomes plus 3x, and we add c. So the answer is 2x cubed minus 4x squared plus 3x plus c. The integration sign. Now we use the sign that looks like a very tall, slim letter S to mean integrate. So instead of writing integrate 6x squared minus 8x plus 3, we could write the integration sign 6x squared minus 8x plus 3 dx. Now the dx at the end of the expression notifies the end of the function to be integrated and the variable that is being integrated. So for example, if you're asked integrate 12x cubed minus 6x minus 7 dx, the answer is that 12x cubed, 12x to the power 3, becomes 12x to the power 4 over 4, minus 6x to the power 1 becomes 6x to the power 2 divided by 2, and 7 becomes 7x, and we add c. So we're left with 3x to the power 4 minus 3x squared minus 7x plus c. In part 2, we're asked to integrate 3x plus 2 times x minus 2 dx. Well, before we can integrate, we need to get rid of all brackets. So this is the integral of 3x squared minus 6x plus 2x minus 4. Now this becomes the integral of 3x squared minus 4x minus 4. Now when we integrate 3x to the power 2, that becomes 3x to the power 3 over 3. When we integrate 4x, which is 4x to the power 1, we get 4x to the power 2 over 2, and the integral of minus 4 is minus 4x, and we must add plus c. So this gives us x cubed minus 2x squared minus 4x plus c. Let's look at a problem. Integrate 9x squared plus 6x plus 4. Well, the 9x to the power 2 becomes 9x to the power 3 over 3, plus 6x to the power 1 becomes plus 6x to the power 2 over 2, and 4 becomes 4x plus c. So this simplifies to 3x cubed plus 3x squared plus 4x plus c. In part 2, we're given the integral has value 23 when x is equal to 2. Calculate the value of c. If x is equal to 2, then 3 times 2 cubed plus 3 times 2 squared plus 4 times 2 plus c equals 23. In other words, 24 plus 12 plus 8 plus c equals 23. So c equals 23 minus 44, or c equals minus 21. Now in part 3 we're asked to write the full integral, and our answer is 3x cubed plus 3x squared plus 4x minus 21. The following is an exercise. You can pause the video at this point and have a go at the questions. The last 3 are a little harder. When you've finished them, start the video again and I'll go through the answers. Okay, let's have a look at the solutions. Now, when we integrate, the thing to do is to raise the power of x by 1 and then divide by that number. So in question A, we've got the integral of 6x squared plus 4x plus 5 dx. Now, when we integrate 6x squared, we add 1 to the power, so that's 6x to the power 3, and we divide by 3. Then we have 4x to the power 1, so we add 1 to the power and divide by 2. For 5, we can just integrate that as 5x, but we must add plus c. So that simplifies to 2x cubed plus 2x squared plus 5x plus c. Now in part B, we're integrating 8x minus 3. Now that's 8x to the 1, so when we integrate it, we add 1 to the power, which makes it 8x to the power 2, and we divide by 2. Minus 3 can simply become minus 3x, and we add c. So that simplifies to 4x squared minus 3x plus c. And in question C, we've got the integral of 8x cubed minus 6x squared plus 5 dx. So 8x cubed becomes 8x to the 3 plus 1, or 8x to the power 4, all divided by 4. 6x squared We add 1 to the power, so that's 6x cubed, and we divide by 3. 5 becomes 5x, and we add c. So that simplifies to 2x to the power 4 minus 2x cubed plus 5x plus c. In part D, we've got the integral of 8x plus 9x squared dx. So 8x becomes 8x squared, and we divide by 2. 9x to the power 2 becomes 9x to the power 3 over 3, and we must add on c. So that simplifies to 4x squared plus 3x cubed plus c. In part E, we have 5x to the power 4 plus 12x to the power 5, and when we integrate that, the first term becomes 5x to the power 5 over 5. 12x to the power 5 becomes 12x to the power 6 over 6, and we must add on c. So that simplifies to x to the power 5 plus 2x to the power 6 plus c. In part F, we're integrating 3x squared plus 5x plus 7 dx. Now 3x to the power 2 becomes 3x to the power 3 over 3. 5x to the power 1 becomes 5x to the power 2 divided by 2. 7 becomes 7x, and we must add c. So that simplifies to x cubed plus 2.5x squared plus 7x plus c. In part G, we're integrating 14x to the power 6 plus 10x to the power 3 plus 5 dx. So 14x to the power 6 becomes 14x to the power 7 over 7. 10x to the power 3 becomes 10x to the power 4 over 4. And 5 becomes 5x. Again, add c. And so that simplifies to 2x to the power 7 plus 2.5x to the power 5 plus 5x plus c. Now in part H, we've got the integral of x plus 4 all squared dx. Before we integrate, we must expand the brackets. So we want the integral of x squared plus 8x plus 16 dx. Now when we integrate x to the power 2, it becomes x to the power 3 over 3. 8x to the power 1 becomes 8x to the power 2 over 2. And 16 becomes 16x. Don't forget to add c. So our result is 1/3 x cubed plus 4x squared plus 16x plus c. Now in part I, we're integrating 3x minus 6 times x squared plus 2 dx. Now we need to get rid of the brackets first before we integrate. So that's the integral of 3x cubed plus 6x minus 6x squared minus 12 dx. Now 3x to the power 3 becomes 3x to the power 4 over 4. Plus 6x becomes plus 6x squared over 2. Minus 6x to the power 2 becomes minus 6x to the power 3 over 3. And minus 12 becomes minus 12x. And add c. So we get 3/4 x to the power 4 plus 3x squared minus 2x cubed minus 12x plus c. Now in part J, we're integrating 3x into 2x plus 3 plus 5 dx. Again, we must expand the brackets before we integrate. So we want the integral of 6x squared plus 9x plus 5 dx. Now 6x to the power 2 becomes 6x to the power 3 over 3. 9x becomes 9x squared over 2. And 5 becomes 5x plus c. So the answer is 2x cubed plus 4.5x squared plus 5x plus c. In part K, we're integrating 6x plus 1 all squared dx. So if we expand the brackets, that's the integral of 36x squared plus 12x plus 1 dx. Now 36x to the power 2 becomes 36x to the power 3 over 3. 12x to the power 1 becomes 12x to the power 2 over 2. And 1 becomes 1x plus c. And so our answer is 12x cubed plus 6x squared plus x plus c. Now, all the powers that we've had up till now have been positive integers, but in fact integration works even if the power is not a positive integer. So in part L, we want to integrate 1 over x squared dx. Well, 1 over x squared can be written as the power x to the minus 2. So when we integrate that, the minus 2 has 1 added to it. That makes it minus 1, and we divide by minus 1. So we have x to the minus 1 over minus 1 plus c, but x to the minus 1 is 1 over x. So the answer is minus 1 over x plus c. In part M, we want the integral of the square root of x dx. Now the square root of x is x to the power a half. So we want the integral of x to the half dx. Now when we add 1 to a half, we get 3 over 2. So the integral is x to the power 3 over 2 all divided by 3 over 2 plus c, which is 2/3 x to the power 3 over 2. But x to the power 3 over 2 is x root x. So our final answer is 2/3 x root x plus c. Or it's equal to 2/3 the square root of x cubed plus c. In part N, we want the integral of 1 over the square root of x dx. Now, that can be written as x to the power minus a half. So when we integrate it, we add on 1 to the power, and that gives us x to the half, and we divide it by a half. Now that simplifies to 2x to the power a half, or 2 root x plus c.